Okay, today we're going to be talking about bivariate data. Hold on. Okay, there we go. Back to the beginning. So univariate data consists of one number for each data value. Statistics, though, often use two sets of data to compare, and this is known as bivariate. A scatter plot is the graph created when plotting points for bivariate data. Do not connect the points. We'll talk about that in a bit. So when points on a scatter plot, so here's some scatter plots, appear linear, we say there is a correlation between the points, and then we can make predictions. The scatter plots below show you strong positive. Okay, we could draw a nice line right through there, line of best fit. This relates to a positive slope, and this is relates to a negative slope. And the farther away the points are, the weaker the line will be. This one has none, no correlation, and I can kind of see some points going through that one. Next. Correlation coefficient is a measurement. It tells you, hey, this is based on this measurement, this has a good correlation. The symbol is an R. So the correlation coefficient is a number between -1 and 1. The closer it is to -1 and 1, the more linear the data is. So here's again some more examples. The -0.99 you can see is real close to -1, and the 0.9 is real close to 1. Those look more linear. And then there's some more down below as well. And if you have one that is R equals 1, it's going to have a line that goes through every single point. So let's see how to set that up on our calculator on the next page. So we're going to turn some diagnostics on. So to do that, should look like that. You go to second 0, which is catalog, and then you want to get D, so you go to x to the -1, and it takes you to the D's. It's already in alpha mode, so I didn't have to hit that button. Find diagnostics on, and then I hit enter twice until it says done. Okay, then I'm going to enter some data, and all of the rest here are directions about how to get the linear regression. But let's first look down below. It says create a scatter plot. So let's first do that by hand, and then you can see it on the calculator as well. So I'm going to have y and x, and I think I'll go 1, 2, 3, 4, 5, 6, 7. And I think maybe I'll start at 20. Maybe I'll start at 20. Right there is 20. Let's see, 24, 28, 32, 36, 40. I think I can go by 4s. 24, 28, 32, 36, 40, 44, 48, and 52. So at 1, we're going to be at 26. Just put a point. 2, we're going to be at 32. 3 at 34. 4 at 37. 5 at 42. Oops. Oh, no, I'm good. 6 at 45. And 7 at 49. Okay, so that's what our scatter plot should look like on our calculator. That looks like it should have a R value close to 1, so 0.9 something. So let's go and use the calculator next to find the correlation coefficient. So we're going to go to Stat, and we're going to go to Edit, and we need to enter our numbers in to our calculator. So I'm going to clear out list 1 and do 1, 2, 3, 4, 5, 6, 7, and then 26, 32, 34, 37, 42, 45, and 49. All right, so I'm going to go to Stat, Calc, and now we do not want one-bar stats. We want lin reg, choice 4. And this is the old operating system, so I have to do second 1, comma, second 2, which is the same thing you did with the standard deviation. So the other operating system, the same thing, except your frequency list is going to be left empty. Nothing in the frequency. It will say list X or something, X list and Y list. Those need to be L1 and L2. But your frequency list needs to stay empty. And then it will also say store regeq, and you're just going to leave that alone as well for now. So in this case, we're just going to hit enter, and there you can see that correlation coefficient is R equals 0.9948. And it also gives us a best fit line. So I'm interested in the correlation coefficient first. So it was 0.994892. And if there is a strong or moderate correlation, write the equation. That's very strong. It's very close to 1, and it looks very close to 1. Let's go back to the calculator and get that equation. So I'm going to, it didn't say to round, so I'm going to write it all out. So it's 3.6785 71429x plus 23.14285,714. That's the equation of my line. So if I go back to the calculator, all I did was plugged in the A and the B, so I have it y equals, mx plus b form. All right, now if you want to take a look at the scatter plot, then you need to come back here and go to the calculator and turn your plot on. So you need to go to second, y equals, and you need to go in there and say, I want to turn this plot on. Okay, so when I turn it on, everything else is fine. X list should say L1, Y list L2. To see it, I go zoom 9. There's the scatter plot. That's what I had. It looks close to mine. Okay. Now, so there was everything, and I saw it on the calculator as well. All right, go to the next one. And we're going to talk about determining the best regression model. Okay, so a lot of times if you just look at those scatter plots that we gathered, you can say, okay, this looks logarithmic, this looks linear, this looks exponential. So exponentials kind of look like this. They do not go through 0, 0. Okay, that's kind of the key because power and regression look similar, but power goes through 0, 0. Okay, so that's an important difference. And logs always kind of look like this, and different than the exponential, a little bit higher up. Our typical log graph is this one right here. Most of the times, though, you're going to be told which regression equation to find. And these are other ones, quadratic and cubic, which you are not responsible for in this course. So let's take a look at, again, graphing these, okay, and getting the best fit line. So there's a bunch of different ones. There's linear, and there's exponential. And I've got two different steps I've got for the old operating system and the new operating system. So here's for the new operating system, Okay. So you're going to do L1 in X list, L2 in Y list, and this is the new thing. We're going to do Y1 vars function so we can store the regression equation. Okay. So it basically says that on all of them. So go to the next page, and you've got logarithmic and power. So those are for you to refer back to. So let's take a look at, let's just do one of these, okay? We're going to look at some extrapolation, which is we're going to be maybe given an x and we're going to need to find a y value, or we might be, so that was this one right here, you might need to enlarge your window, and then you can use second calc value. You'll see x, and then you put in the value of x you're looking for, and a corresponding value of y will appear. If you're given y, then you would be typing the given value into y2 equals, and you find the intersection. So let's take and enter some data here. All right, and it tells you to do a linear regression. Okay, so let's go to the calculator and do that. So go to Stat, Edit, and clear out list 2. And clear out list 1. All right, and let's type in period 1. Okay, there's period 1, and let's get in period 2, or period 5. Okay, they should match. And they do, yes. All right, good. So we got them all in. Make sure you've entered them correctly. So now it says determine the appropriate linear regression model. Write the equation, list calculator steps, find the correlation coefficient. All right, so let's do this. Stat, calc, choice 4, lin reg. Second 1, comma, second 2, unless you have the new operating system. Now, what I'm going to do is store the regression equation into y1. So I'm going to do another comma. Those of you with the new operating system, you need to look back at your notes, and it will tell you you're just going to the store regression equation part, and you're doing the same thing as us, except we have a comma. You do not. Then we're going to go to vars, y vars, choice 1 function, and y1. So what we're telling is we want to store the regression equation in y1. And then we hit enter. So this is the equation of our line. So the correlation coefficient is 0.555. Don't look at the r squared. And the equation is right there. So I'm going to write this down. So the correlation coefficient is r is equal to 0.555. I'd say that's, it's definitely, is the correlation positive or negative? Is it strong, moderate, or weak? I would say moderate. And is it positive or negative? It was positive because it's not negative 0.555. So it's not the best to use, but we're going to answer the questions with it anyways. Their equation was 0.6351. Yep. There was no mention of round. Oh, round the coefficients to 3 decimal places. Okay, so it's 0.635 x plus 29.364. Calculator steps were stat, and this was L1 and L2, so it was stat, edit, stat, calc, and we did lin, reg, it was choice 4, and we had L1, comma, L2, comma, Y1. Now, for the others of you, you would just have X list, was L1, Y list was L2, and your store regression was Y1. Okay, and that's, you get to this part here by doing vars, Y vars, function. Okay? All right, next, predict the period 5 test score correlating to a score of 97. So this is where we need to go back and look at what this looks like in terms of our graphs. So if we go to y equals, I already have the plot on from the first one we did. There is my regression equation that I just found. If I, from here, just go to zoom 9, it will draw in the scatter plot and the best fit line. So the scatter plot was 0.555, so they are kind of scattered. It makes sense. What I need to do is to predict the period 5 test score correlating to a score of 97 from the student in period 1. So I need to go to that window and make sure that the X max is larger than 97. And it is, but I'm going to change it to 100. And then I'm going to go to second trace value, which is choice 1. And I'm going to ask it, when X is 97, what is Y? So Y is 91 to the nearest integer. So when X was 97, Y was 91. Okay? So for that one, I looked at, zoom 9, and I went to my X, my window, and I made my X max equal to 100, and I did second trace value, and when it said X's, I put in 97, and then it gave me the Y value. All right, and then for D, predict to the nearest integer the period 1 test score correlating to a score of 97 from a student in period 5. So I think we need this backwards. So now I know Y is 97, and I'm looking for what is X. So this one we have to do a little bit differently. I'm going to, first of all, go to Y2, and I'm going to put the 97. So let's check that out. So go back here, type in Y2 97. Let me just change this back. Okay, and then if I check my window, my Y max needs to be higher than 97. It is, so I'll just hit graph. Oh, but you see, I can't see the intersection, so I'm going to go to that window, and I'm going to change that X max to 110. Now, this might be a problem, because can you get a grade higher than 100? No, so not usually. Then we're going to do second trace intersect, enter, enter, enter. And the intersection's at 106, so when somebody in the other period has a 97, that means then the first period class would have a 106. And that's really not going to be likely to happen. So that's really not going to be likely to happen. But that's what I'll leave as my answer. So we went to y2, and we went to a graph, and we checked the window again, and saw the intersection wasn't quite right, so we changed the x max to 110. And make sure that the y max was larger than 97. So we'll say it was like 99 point something. We'll put it at 100, and then we did second trace intersect. All right, and that should do it for today. Thank you.